So we need to balance sulfur by adding 2. So now it reads, we now have on the left 2s for the 2s, that is hydrogen sulfide. Remember that 2 multiplies all the H2S and S for the SO2. Therefore, we must have 3s on the right and the balancing is complete. What we now have is 2H2S plus SO2 to give 2H2O plus 3S. The equation is balanced because we are now having, if we count the number of sulfur at the product, it is now 3 because 2 times S will give us 2 molecules of hydrogen of sulfur from the left hand side plus that of sulfur 2 oxide on the right hand side of the left hand side to give 2 molecules of hydrogen, that is 2 molecules of water plus 3 molecules of hydrogen. What I'm saying here is that all the atoms, hydrogen is 4 at the right hand side and 4 at the left hand side. Sulfur is 3 at the right hand side and 3 at the left hand side. Oxygen is 2 on the left hand side and 2 on the right hand side. This is some, now it reads, some such balancing process is necessary for all equations, but many of them become so familiar with frequent use that they can become set down correctly at once. Law of conservation of matter. The law of conservation of matter states that matter is neither created nor destroyed, but it can change from one form to other in the course of chemical reaction. An unbalanced equation would imply that atom has been created or destroyed. When balancing the chemical equation, we must remember the following: that the formula of reactant and product in an equation are fixed and cannot be altered. So the only way to balance chemical equation is by taking appropriate number of moles of reactant and product consigned and do an atom count to check the equation is balanced. To balance the equation for the combustion of ammonia gas in air, the reactant at the left hand side are ammonia NH3 and oxygen O2, which the product are the right hand side nitrogen 2 oxide and NO and water H2O. Ammonia NH3 plus O2 to give NO plus H2O. We now place 4 in front of NH2 and a 6 in front of H2O. We do this placement in a matter to balance the atom count, either by trial or error or by maybe exact assumption of what you are doing. There are now 12 hydrogen atoms on both sides of the equation. We are now having 4H and H3, that is 4 times 3 for H3, will give us 12, plus oxygen 2 to give NO, that is nitrogen 2 oxide plus now plus water, which is H2O, which is, hydrogen there is 6 times 2, which is now 12. The hydrogen is now balanced, but the nitrogen at the product, that is the left hand side, is still not balanced with the nitrogen. The nitrogen oxide is 1, while the nitrogen inside the ammonia is almost 4. Likewise, oxygen is not balanced. We are having oxygen to be 2 atoms at the product, that is the left hand side, and it is almost 7 at the right hand side, that is the product. Then I read placing 4 in front of NO to balance with the 4 nitrogen atom on the left hand side of the equation. We now have 4NH3 gas plus 5O2 of oxygen to give 4, which is nitrogen 2 oxide plus 2 plus 6 water, molecules of water, H2O. Now, if we check the equation, oxygen is 6 at the oxygen is 10 at the product. When you look at the reactant, it is also 10 because nitrogen 4 oxide is having 4 molecules of oxygen because NO is being times by 4, and the water is having 6 molecules of water, oxygen. Therefore, it is balanced. Oxygen is balanced. We are now placing 5 in front of oxygen. An atom count shows that the equation is balanced. That means N4H3G plus plus 5O2G to give NOG. The G there is gas plus 6H2O gas.